Welcome to News About Geology. Today, we're diving into a question that is, fundamental for every geologist. In a world that seems completely driven by chaos, how do we find any order? How do we even begin to predict the unpredictable right under our feet? Okay, so here's our game plan. We're going to kick things off with the huge challenge geologists are up against, and then we'll really question what random even means. From there, we'll uncover some of the hidden patterns inside all that chaos, check out the tools that help us make sense of it, and finally, kind of reframe how we look at modeling our entire planet. So let's start with the big one, the core challenge. I mean, every geologist, every earth scientist is tasked with trying to model systems that are just infinitely complex. We're talking about everything from the tiny grains in a single rock all the way up to the massive sweep of a mountain range. And this quote from the US Geological Survey it hits the nail on the head. An exact description isn't just tough to get, it's actually impossible. Seriously, think about trying to map an oil reservoir or some mineral deposit that's buried deep underground. We are trying to describe this vast, ridiculously intricate system that we can never, ever fully see. This is what we call the geologist's dilemma. We have to model these enormous systems based on just a few little samples, a couple of boreholes, maybe some seismic lines. It's like trying to draw a map of a hidden city by just peeking through a few keyholes. So you see, uncertainty isn't some flaw in our method, it's a fundamental reality of the job. And this forces us to ask a really critical question. Is all the variation we see in our data truly random, like static noise? Or is there some kind of hidden structure that we're just not seeing? But hey, before we can even answer that, we have to figure out what random actually means. In statistics, when we say something is random, what we really mean is that it has no predictable patterns. It's kind of like the results you get from a perfectly fair dice roll. There are no regularities, no clues you can use to guess what the next number in the sequence is going to be. Now, what's really fascinating about this is how early scientists started trying to pin this stuff down. We're talking way back in 1938. They came up with these clever statistical tests, like the poker test, which, literally looked for the kinds of patterns you'd find in poker hands, all to check if a sequence of numbers was behaving the way pure chance says it should. Exploring these deep concepts where math and geology collide is what modern geology is all about. And if you think this stuff is as cool as I do, you should definitely go visit PGO Ricardo Val's channel on YouTube. He's got some absolutely fantastic explainers on this. But here's where it gets interesting. What if some of that randomness we see in nature isn't actually random at all? What if it's the result of something far more structured, yet somehow just as unpredictable? This is where we get into the wild world of chaos theory. And this is the central paradox, isn't it? How can something follow strict, fixed, deterministic rules, but still be totally unpredictable? I know, it sounds like a contradiction, but as we're about to see, it's a fundamental property of our universe, and it governs everything from weather patterns to the way water flows. The answer is in a concept you've probably heard of, the butterfly effect. The more formal name for it is sensitivity to initial conditions. And what it means is that even the tiniest, most microscopic difference in where you start can lead to these massive, unpredictable differences down the road. It completely ruins any attempt at a precise long-term prediction. Okay, look at this slide. It shows the idea perfectly. On the left, a system starts with the value 0.31. On the right, it starts at 0.310001. That is a ridiculously small difference. And both systems follow the exact same simple rule. But watch what happens. For the first few steps, they look almost identical. But pretty quickly, that tiny starting difference gets blown up, and their paths just go completely different ways. They end up looking totally random, even though they were perfectly deterministic the whole time. So, is there any order in all this chaos? Well, yes. It's found in something called a strange attractor. The best way to think of it is like a hidden map that this chaotic system is forced to follow. The system's path will wander along this incredibly complex fractal shape forever. It never repeats itself, but it's always confined by this structure. It's the beautiful, hidden pattern inside the randomness. All right, so that's some pretty mind-bending theory. How do we actually apply this stuff to the very real-world challenges of geology? Well, this is where the Geostatistical Toolkit comes into play. It all connects through the field of geostatistics, which uses these really powerful software tools, like the one you see here, to analyze spatial data. This is how we bridge that gap between the high-level theory of chaos and the practical reality of, say, a drill core log. And this slide shows you the very first, very concrete step. These tools take that raw data from the field, coordinates, measurements, depths, and they structure it. Before any of the fancy modeling can begin, we have to tell the software exactly what our data is and where on and in the Earth it came from. So at its heart, geostatistics gives us a mathematical framework to deal with all that uncertainty. It uses powerful techniques to make really intelligent guesses about what's happening between our sample points. For example, Kriging is the sophisticated method for estimating values in places we haven't actually drilled, all based on the data we do have. These tools help us build models that embrace the complexity instead of trying to pretend it doesn't exist. And all of this brings us to a really profound shift in how we look at things. When we combine our geological knowledge with chaos theory and the power of geostatistics, we don't just get better models. We get a fundamentally new way of understanding our planet. What's amazing is that over a century ago, the brilliant mathematician Henri Poincaré absolutely nailed the essence of chaos. He realized that when a system is super sensitive, our inability to know the starting point perfectly means prediction becomes impossible. The outcome just appears, as he put it, fortuitous or random. And this, right here, is the ultimate takeaway. The goal isn't to create one single perfect model of the Earth, because that's just impossible. No, the real goal is to create robust models that embrace the planet's inherent chaotic nature. We build models that give us a range of possible outcomes, honestly reflecting the uncertainty we know is there. This leaves us with a final thought to chew on. We've seen how geology can hide these deterministic rules under a veil of what looks like pure randomness. So where else in science, or heck, even in our daily lives, might there be an underlying order in what seems to be complete and utter chaos? If this has sparked your curiosity, I highly, highly recommend visiting PGeo Ricardo Valls' channel on YouTube for more incredible deep dives into the world of geology. Thanks for watching News About Geology.
Welcome to my channel, where you'll find over 2,000 videos on geology, geochemistry, AI, and many other subjects. If you like what you see, help us grow by subscribing, liking, and sharing this channel.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.